Welcome to Signals and System subject classes. Now we are in the fifth chapter, that is continuous time Fourier transform. So in the chapter, this is the fourth video. Previously, we have discussed about properties of the continuous time Fourier transform. Now, in this video, we are going to learn application of the duality. Here, I am taking one impulse signal. You know that Fourier transform of the impulse signal, that is one. So, for example, this x of t equal to del of t. So, its Fourier transform. E is 1. That is x of j omega equal to 1. Then, what is the Fourier transform for the 1? So this is continuous time Fourier transform. So, for the 1, so what is the Fourier transform? We know the duality property. The duality property, here I am writing, so we need to find the Fourier transform of the 1. So for that, I'm taking this reference. So inverse Fourier transform, that is del of t. This is inverse Fourier transform, that is equal to 1 by 2 pi integral minus infinite to the plus infinite. That equal to x of j omega equal to 1 into e power j omega t into d omega. For this case, so what we have to find Fourier transform this one, is it? So that is what? That is nothing but the Fourier transform of the one, the formula minus infinite to plus infinite. So 1 into e power minus j omega t into dt. So this integration we should find it, is it? So this integration is nothing but Fourier transform of this one. So I'm going to convert this equation to this equation. So for that, there is no 1 by 2 pi. So there is a 1 by 2 pi. I am sending to the left side. So 2 pi into del of t, that equal to integral minus infinite to plus infinite. So 1 into e power j omega t into d omega. Then here this is integration with respect to t. So this one is integration with omega. So this I'm going to replace t equal to omega. So interchangeable. So that equal to, so we can change interval 2 pi del of omega, that equal to integral of minus into plus infinity. So 1 into e power, so j into, so omega equal to t equal to omega. So then we get same equation, omega t. So in place of the omega, there is a t. Now compare this one. So this is integral of minus into plus infinity 1 into e power minus. So I'm going to replace by omega by the minus omega 2 pi del of minus omega, that equal to minus infinite plus infinite into e power minus j omega t into dt. So Same equation here we are getting. So integration minus infinity plus infinity 1 into e power minus j omega t. See here, we know that del of minus omega equal to del omega. Why? Because impulse function it is having magnitude at omega equal to 0 only. Is it? Then so 2 pi del of omega both are same 2 pi. So the time reversal of impulse it will be same impulse signal. So minus infinite plus infinite. So 1 into e power minus j omega t into dt. So what we are getting here? So one Fourier transform that equal to 2 pi into del of omega. So this is it is called duality property. Is it del of t Fourier transform one Fourier transform equal to del of omega 2 pi. So this is a constant. Almost. So this is the case. So another application. So that is so before that you know that e power minus at into u of t, its Fourier transform is its Fourier transform is 1 by sorry actually so mm, e power minus a mod t. So this is it is nothing but e power for positive it is minus a t into u of t plus e power for negative it becomes negative e power at into u of minus t. So this is the e power minus a mod t. So this is Fourier transform. So my e power minus a mod t mod t. So it's Fourier transform. It's Fourier transform. Already we have derived it 2a by a square plus omega square. Continuous time Fourier transform. Now, so e power 2a by a square plus t square. So what is the Fourier transform? So what is the Fourier transform? Same duality, same concept. So here, so for one, so we can write directly 2 pi into e power minus a mod omega. So before that, I want to prove it. For that, first, first of all, what we want to find this is Fourier transform. So there's Fourier transform. So integral of minus infinite to the plus infinite. So 2a by a square plus t square into e power minus j omega t into dt. So this is Fourier transform. Fourier transform of the 2a by a square plus t square. Here I'm taking this is reference. So e power. So this integration we should find it. Integral of minus infinite plus infinite 2a by a square plus t square e power minus j omega t to dt. This integration we have to find it with help of this relation. So that e power minus a mod t. So that equal to, so this is inverse Fourier transform that equals to 1 by 2 pi integral of, so minus infinite to the plus infinite. So it's 2a by a square plus omega square into d omega. So this is the integration with respect to t, this is integration with respect to omega. So same case, interchanging the t to omega, omega to t. E power, so there is no, so here in integration there is no multiplication. So you shouldn't have 2 pi. So send to the left side, so 2 pi into e power minus a, and change the variable from omega to t. So t is replaced by the omega. So that equal to integral of minus infinite to the plus infinite. So now, so 2a by a square plus, sorry, I forgot here. What is it? E power j omega t into d omega. 2a square omega. So here omega must be replaced by t square. So e power. So there is no change. Why? Because omega is replaced by t by omega. So then same we will get it. So omega t here, this is dt. Now change the omega by minus omega. So 2 pi e power minus a. So the minus omega. So that equal to integral of minus infinite to the plus infinite by 2a by a square plus t square into, here we will get omega must be replaced by minus omega. So minus e power minus j omega t into dt. So here this we have the, this is mod. So mod of this minus, it becomes positive. We know that. So 2 pi e power minus a mod of omega. So that equal to integral of minus infinite to plus infinite 2a by a square plus t square into e power minus j omega t into dt. So this is the answer. So this is the so Fourier transform formula. See here, integration minus into 2a by a square plus t square e power minus j omega t. So this is equal to what? So this is equal to, so 2 pi into e power minus a mod omega. So Fourier transform equal to 2 pi into e power minus a mod omega. So this is the, so this is about duality property. See, this is duality property. So this is about duality. So the concept is duality. Next, next topic. Still now, we converted the time domain to the frequency domain for the upgrade signal. So in this concept also, in this continuous Fourier transform also, it is applicable for the periodic. So now, so for continuous time, continuous time, Fourier transform, Fourier transform, Fourier transform for periodic signal. So this topic also is very, very important. So in this case, I would like to take the periodic signal in continuous time. For example, one periodic signal, x of t, is a periodic signal. So Fourier series representation, you know that ak into e power jk to omega naught into t, k from the minus infinity to plus infinity. You know that, is it? For this case, Fourier transform of this periodic signal, that equal to directly here I'm writing that Fourier transform. So actually this x of t, you can, this x of t, it's a Fourier transform. So that is x of j omega, continuous time Fourier transform, continuous time Fourier transform. So directly here I'm writing, so this is directly you should remember the Fourier transform x of j omega equal to, that equal to, so 2 pi ak into, so this is impulse train in terms of omega minus k into omega naught. So this is from k minus infinity to plus infinity. Just substitute ak value in this equation, then we will get the Fourier transform corresponding that signal. So this is the case. So this is the case. Here we have to find it Fourier transform for the period signal. So for example, before going to this Fourier transform for the period signal problems, I would like to tell about properties applications. See, del of t, we know that del of t, its Fourier transform is del of t Fourier transform is 1. Then 1 Fourier transform equal to, that equal to 2 pi into del of omega. Then what is the Fourier transform? So these are the continuous time Fourier transform. It is also continuous time Fourier transform. Then what is the Fourier transform for the e power j into omega naught into t? So what is the Fourier transform? See, so here this one Fourier transform is equal to 2 pi into j del of omega. Then here this is, I'm assuming this is 1, is it? So this 1 is multiplied by the exponential. So what property we should apply? Frequency shifting. So what is the frequency shifting property? So frequency shifting, so x of t, it's Fourier transform equal to x of j omega, it's Fourier transform. Then x of j omega minus omega naught. So this is frequency shifting. So frequency shifting, just multiply with the exponential. Here this is delay, so should take the advance plus e power j into omega naught into t. So this is frequency shifting property. This is called, this is, so already we discussed in the previous classes, frequency shifting property. Frequency shifting property. So here compare this one, then we will get it. So 2 pi, so 2 pi, sir, here this exponential is multiplied, is it? Here 1, this is x of t, the x of t. So e power j omega naught is multiplied. Then you apply frequency shifting. So that equal to 2 pi. So x of omega must be replaced by the omega minus omega naught. So 2 pi. So del of omega minus omega naught. Same case for the e power minus j omega naught, that equal to, so that equal to, so x of j minus omega plus omega naught. Sorry, 2 pi. 2 pi del of omega plus omega naught. So now we know that one periodic signal, so that is represented in terms of the Fourier series representation. So that is put ak into e power jk omega naught into t, k from the minus infinite to plus infinite. For this case, what is the Fourier transform? So x of, it's x of j omega, that equal to sigma, so 2 pi into ak into impulse train, so omega minus k into omega naught, k from the minus infinite to the plus infinite. So this is the next one, next problem. So these are the problems. So next periodic signal I am taking here, this is x of t. This is also periodic signal, that is cos omega naught t. Cos omega naught t. So this is a periodic signal. Then there are two ways to find the Fourier transform. You know, convert this cos omega naught t into exponential. Already we have here, we have the formulas, is it? Otherwise, find the Fourier series coefficient for this periodic. Then substitute AK in this equation, then you will get the Fourier transform, is it? So in the first case, this is the first method. So in first method, first of all, I am converting this to the exponential that equal to e power cos theta equal to e power j theta. So omega naught into t plus e power minus j into omega naught into t by 2 by 2. So this is a periodic signal. Periodic signal. So it's Fourier transform equal to. So it's Fourier transform. So continuous time Fourier transform. So that equal to first e power j omega naught t Fourier transform equal to 2 pi into 2 pi into del of omega minus omega naught. Next place, linearity property. So addition, then in frequency domain also we will get the addition. So e power minus j omega naught is its Fourier transform equal to 2 pi del of omega plus omega plus omega naught, then divide by 2, divide by the 2. So 2 gets cancelled. Then finally we will get so the cos omega naught, its Fourier transform. So its Fourier transform that equal to pi is a common. So pi is a common. So del of omega minus omega naught plus del of omega plus omega naught. So for the sine function, we know that sine function. So x of t for the sine function sine omega naught t. So that equal to in terms of the exponential e power j omega naught t minus e power minus j omega naught t by 2g. So it's a Fourier transform. So it's Fourier transform. So e power j omega naught t Fourier transform that equal to 2 pi del of omega minus omega naught minus 2 pi del of omega plus omega naught by 2z. So 2 gets cancelled. Then we'll get sine omega naught t. So Fourier transform. It's Fourier transform. So pi j is a common. So pi by j equal to del of omega minus omega naught minus del of omega plus omega naught. So advanced signal having the negative sign. So that is the difference. So this is one method. And also we can find the this Fourier transform with help of the Fourier coefficient, this formula. So finding the Fourier transform in this method, so we should find the Fourier coefficient for the cos and sine. I'll show you. So see this cos omega naught t. So in exponential we can write like this 1 by 2 into e power j into omega naught into t plus 1 by 2 into e power j into, so here this is, I'm assuming minus 1 into omega naught into t. So here this is magnitude equal to 1. So this is like, this is Fourier series representation. So this is the k value equal to 1. This is k equal to minus 1. So this 1 by 2 is a1 equal to value. So this 1 by 2, it is equal to the a minus 1. So this is the Fourier series representation for the cos omega naught t. Then that Fourier series coefficient ak, that equal to 1 by 2, 1 by 2 for k equal to 1 and minus 1, 0 otherwise, not equal to 1 and minus 1. So Fourier series, we can write like this, a minus 1 equal to a1, that equal to 1 by 2. It is also correct. So the Fourier series, Fourier transform for the period signal, that equal to x of j omega equal to sigma. So here k having the only two values. One is k equal to 1, k equal to minus 1. So in this, first of all, I'm writing formula minus infinite to the plus infinite, ak into 2 pi into del of omega minus k into omega naught. So, so in this case, ak having only two values. One is 1, another one is minus 1. So a1, so 2 pi is a common. Okay, 2 pi is a common. a1 del of omega minus omega naught. Next one, plus a minus 1 del of omega minus of minus plus omega naught. Next, substitute a1, a minus 1 values. So 2 pi a1 equal to 1 by 2. So del of omega minus omega naught plus 1 by 2 del of omega plus omega naught. So 2 gets cancelled. Then we are getting here cos omega naught. It's Fourier transform. Continuous time Fourier transform. That equal to, so pi is a common. So pi is a common. So del of omega minus omega naught plus del of omega plus omega naught. So this is the case. For the similarly, we can write for the sine function also, sine periodic, sine omega naught t. So sine omega naught equal to, we know that e power j omega naught t minus e power minus j omega naught t by 2j. Here I'm writing here 2j and 2j. So this is k equal to 1, k equal to minus 1. Then, but signs are different. Here it is having positive, here negative. Then you can write like this. So a1 equal to 1 by 2j and a minus 1 equal to minus 1 by 2j. So these are the Fourier coefficient values. So from the x of j omega, so that is 2 pi. So 2 pi. So we know that formula. So sigma ak into 2 pi into del of omega minus k into omega naught, k equal to minus infinite to the plus infinite. So 2 pi a1 del of omega minus omega naught plus a minus 1 del of omega plus omega naught. Now substitute Fourier coefficient value a1 equal to 1 by 2j. So del of omega minus omega naught by 2j. Here this a minus 1 is it is a negative. So that equal to minus del of omega plus omega naught by 2j. So 2 gets cancelled. Then the sine function sine omega naught t, it is a periodic signal. So periodic signal continuous Fourier transform that equal to pi by j. Pi by j is a common. So that equal to del of omega minus omega naught minus del of omega plus omega naught. So here I would like to write time domain function and frequency domain. For that, so in time domain, the cons function is, so cons is a event signal. So this is event signal. Cos omega naught t, for this case, continuous time for a transform. What we are getting here? Two impulses. Two impulses. So one, so this is x of j omega. So impulse functions. One it del of omega minus omega naught, impulse it to omega naught. This is omega naught. This is minus omega naught. This is omega naught. So del of omega minus omega naught. So this is, so this is, it is also having positive. So this is del of omega minus omega naught. This one is del of omega plus omega naught. Its magnitudes are, it's better to write this is. So in communication systems, these are very, very important communication system for the modulation techniques. So coming to the sine function, so this sine function, So this is omega naught minus omega naught. So this is impulse at omega naught. So it is shifted to right side. This is left side. Left side shifted. The magnitude called pi by j del of omega minus omega naught. So this is minus pi by j del of omega plus omega naught. Excellent. So this is about Fourier transform for the periodic signal. So these are the very important for the electronics and communication graduates while studying the modulation analog modulation techniques, in especially in amplitude modulation techniques. These are very important. So because of that, in for modulation technique, always cos omega naught it is preferred. So this is the case. Next class, we will discuss some more problems. Thank you.